Hello.
Hello.
Hi Diksha Didi. Good evening.
Hi.
So yesterday we stopped on while loops and today we are just gonna continue with while loops. So I hope you can see my screen.
Yeah, it's visible.
Alright. So let's just continue. So we saw for loops and all, and we saw the example of vectors also, and we saw how to use for loops. So let's just start. So while studying for loops, we have seen that the number of iteration is known beforehand. So we know the number of iterations we have to do beforehand in the for loop only. Like the number of times the loop body is needed to be executed is known to us, right? So while loops are used in situations where we do not know the exact number of iterations the loop beforehand, right? So if we do not know the number of iterations of the loop beforehand, then we'll use while loops. So the loop execution is terminated on the basis of the test conditions. So once a test condition is true, the while loop will run, and once that test condition is false, the while loop will stop. So we have already stated that a loop mainly consists of three statements: initialization, expression, test expression, and update expression. So the syntax of the three loops for, while, and do while mainly differ in the placement of these three statements. So the difference mainly is the placement is where these three statements are placed, right? So the initialization expression in the for loop, we're just gonna just go back there, and over here we see the initialization expression in the for loop is given over here, the test expression over here, and the update expression over here, and the body of the loop inside, right? In while loops it's different. In while loops the initialization expression is given over here, the test expression is given over here, and after the body of the while loop is executed, the update expression is given in the end, right? So this is a typical while loop where you'll have the initialization expression over here, then you'll have the test expression that will test some condition. If it will give true, then it will go inside the while loop, it will execute the loop body, right? So that will be over here, and then the expression will be updated, and then again the test condition will be seen, right? So this is the while loop, a typical while loop. So here's the flow chart of the while loop also. So the while loop starts over here, then there's a test condition. If it's true, then the loop body is executed, and then it goes back to the test condition. But if it's false, the while loop ends, right? So this is the flow chart of our while loop. So here's an example of a while loop. So over here in the main method, we have I equals to 1, and we are checking while I is less than 6. So while 1, first it will check 1 is less than 6. So this is true, this statement over here is true, right? So it will go inside the while loop. So this is the initialization expression over here, this was the test expression, right? Now this is the body, right? So in the body we have just given this much, right, that to print hello world, and then we are this is the update expression that is incrementing the value of I. So first it checks 1 less than 6, so that's true, so it goes in and prints hello world, then it updates I. So now I is 2, right? So then it again checks 2 less than 6, that's true, so it will go in and print hello world, and then it will update I. And when i's value will update and it will reach 5, then it will check 5 less than 6, it is true, so it will go in and print the value hello world, then it will increment the value of I. So now i's value is 6, and now when i's value will be 6, it will check 6 is less than 6, so 6 is not less than 6, so it will exit the loop. So in the end we'll get hello world, we'll get hello world 5 times. So we are getting hello world, hello world, hello world, hello world, hello world. Another way or to do this, instead of I less than 6, we could have written less than or equals to 5. So this would have done the same thing for us. Hello world, hello world, hello world, hello world, hello world. So is this example clear of the while loop, the initialization expression, the test expression, the body, and the update expression?
Yeah, it's clear.
Alright. So this was a normal normal while loop. We are gonna see many examples, but very similar to the while loop is our do while loop. So we're gonna see that first. So do while loops for is new for us. We didn't do that in the basic course. So in do while loops, also the loop execution is terminated on the basis of test conditions. So on the basis of test condition only, the loop is terminated. And the main difference between the do while loop and the while loop is that the in the do while loop the condition is tested at the end of the loop body, meaning that do while loop is exit controlled, whereas the other two loops are entry controlled. So the while loop and the for loop are entry controlled, the do while loop is exit controlled. So in a do while loop, first it will enter the do while loop, it will execute that code, uh, then it will after executing the code it will update the expression inside the do block only. After executing the full body, then it will go and test the check for the test expression. If that will be true, then only the execution will be continued. So regardless if your condition is true or false in do while loop, once the code will be executed, the body of the loop will be once executed every time. If your condition is true or false, every time in do while loop your code will be executed. So we are gonna see that in an example also. So in a do while loop, the loop body will execute at least once, irrespective of the test condition. So irrespective of the test condition, the loop body will be executed at least once. So here you have an initialization expression. So then after initialization of the expression, it will go inside the do block. It will execute the do block regardless of the condition. It hasn't reached the condition till now. So it will execute the do block. Then it will check whether the condition given to while is true. If it's true, it will go back and execute the do block, whatever is there in the do block. Else, it will just quit the do while loop. So once at least once your do while loop will get the do while loop's body will get executed, right? So the semicolon at the end of the while loop is mandatory, right? So without that, it will lead to an error. And here we have the flow chart of the do while loop. So we have the do while loop that starts, then it executes the loop body. After executing the loop body, it checks the test condition. If that's true, that will go back and execute the loop body, and then it will check the test condition. If that test condition is false, it will just end the do while loop. All right, is it clear?
Yeah, it's clear.
All right. So here's an example. We have I equals to 2, that is an initialization expression. Then it will go in the do block. It will print hello world, right? And then it will update the expression, right? So then I will be 3. Then it will go in the while. It will test the condition. It will check 3 less than 1. So 3 less than 1 is false. So it will come out. So we'll get hello world on the screen from this program. Alright, so we are getting hello world once, as it went in the do block, it executed hello world, and then it found the condition to be false, so it executed the do while loop. So in the above program, the test condition I less than 1 evaluates to false, but still, as the loop is an exit control loop, the loop body will execute once. Alright, so now what about an infinite loop? So we have infinite loops also in C++. So an infinite loop, sometimes also called an endless loop, is a piece of coding that lacks a functional exit so that it repeats indefinitely. So your infinite loops will never exit, right? And they will at any cost never exit, right? So an infinite loop occurs when the condition is always evaluated to be true. So usually this is an error. Usually when you encounter an infinite loop, it will lead to an error, but it will occur when your condition is never false and it's always true. So over here we have the example of all the of some infinite loops. Over here we have for we are saying semicolon semicolon. So this part evaluates to true for it. So for we are saying true, and for receives true only. So because we for is never false. This is an infinite for loop, right? As the condition expression is blank, the condition expression is blank. So over here you have initialization nothing, then the test condition nothing, right? So you have int I over here. So over here we are just not initializing, right? So I missed some one point. We are saying int I over here, so we are not initializing. In for loop we had initialization, then we had the test condition, and then we had the update statement. So we are not giving any test condition, we are not giving any update statement, right? So the for loop does not have any test condition to check on. So the test expression is blank, right? So like as the condition expression is blank, so when the condition expression is blank, it will always go in the for loop and execute. This loop will run forever. So this for loop will never end, and this will show this loop will run forever, again and again, right? Until the program has, you have to halt the program, or C++ will forcefully stop the program. Next, over here you can see the commented part, that is an example of an infinite while loop. So over here we have while I not equals to 0. So we are checking I not equals to 0, and we are decrementing I. So in start I was 0. So till I in the start I was something else, right? So we if we say it's like, let's just say it's equals to this. This is not an infinite loop. Geeks for Geeks has given a wrong example, right? So as if you let's just comment this code over here, because in the we over here said int I. Geeks for Geeks over here said int I. So i's value in start could have been anything, right? So if it was allocated, some we saw in the variable chapter that when you only declare the variable, it is allocated a memory location with some garbage value in it. So if that garbage value is like greater than 0, right? So it will go in, and if for example the garbage value allocated to I is equals to 1, so I will be not equals to 0, it will decrement I, and this it will show this loop will run forever, right? But then I will be equals to 0, and this condition would evaluate to false, so it will come out of the while loop, right? So the if the garbage value is like greater than 0 or something, then the while loop will end, right? So we are not sure if the garbage value will always be less than 0. The garbage value that needs to be allocated to I should always be less than 0, but it's not compulsory over here. It will be less than 0, it could be less than 0, it could be equals to 0, or it could be greater than 0. So by a value, the initial value for I over here could be anything, right? So we have to specify it, give it less than 0 to make this an infinite loop. As when it will be less than 0, it will be not equals to 0, so it will keep on subtracting, and it will then be -2, then -3, then -4, and till minus infinity, and minus infinity it will keep on subtracting I. As when subtracting -1, you can never reach 0, right? So this loop will run forever in this case, right over here. But if we give I like this, it's not compulsory it will run forever. Let's just run this to see if, right? So we got no output. So this time let's just see once again. So we got no output over here. Why? Because in the start i's value, I believe, will be 0 only, right? So i's value is given 0, right? So i's value in the start is given 0 now, right? So the memory location allocated to I must be having the value 0. So when it says 0 not equal to 0, that is false, so there's no output. Let's just see out something outside the while loop also, just to make uh, like high or something, right? So if we run this code, we are getting high. So it's not going in an infinite loop. As int I, when we say int I, it's allocated a garbage memory location. So whichever garbage memory location it is getting allocated, it has a garbage value of 0. So right now, so when it checks 0 not equals to 0, that is false, so it comes out and just shows high, right? So this is not actually an example of an infinite loop. An infinite loop example would have been like equals to -1 or equals to -2, right? So this would have been an example of an infinite loop. Now thirdly we have another example. So over here we have another example of the while loop where this is an infinite loop. So here there's nothing to do with I, we are giving while true. So every time while the while loop will get true, right? So whenever while loop gets true, it gets executed. So now over here, this where the test condition needs to come, over here it's always getting true. So while loop will test condition will never be false, so it will always go in and show this loop will run forever, and it will infinitely show this loop will run forever, right? So here were three examples: the for loop example, the while loop example. But this example over here, that was this while loop was not complete, right? So the example of this while loop being an infinite loop was not complete. But this is a guaranteed infinite loop, this is an infinite loop, and this also can be an infinite loop, right? So over here we saw some examples of infinite loops. So I hope they're clear. If you have any doubts, you're free to ask. Feel free to ask.
No, I don't have no. It's clear.
All right. So now over here, there's one more example. We over here give while true. We can also give while one. So one is a value, so it is basically true. The value will return true only. So when while receives true, it will never end. Right. So this all example also is of an infinite loop. Now here we have a do while loop, infinite loop example, right? So over here in do, we are saying see out this loop will run forever. So it will go in, it will show this loop will run forever, then it will check while one. So now we are similarly over here giving while one. So while true, so the test condition will never be false, so it will in the loop will run infinitely, right? And this loop will never stop. The do while loop example also we have seen of an infinite loop. And over here we have a for loop example also. There we just gave uh, uh, we gave no test condition, but with a test condition also. Here's the for loop example that will lead to an infinite loop. So we have I equals to 5, I greater than equals to 0, I minus minus. So this is not an infinite loop example. So right, so this is not an infinite loop example. This is a decrementing loop. All right, so the infinite loop examples have been completed, right? This is a decrementing loop example. So sometimes we need to decrement a variable with a loop condition. So like we have for int I equals to 5, I greater than equals to 0, I minus minus. So first I will be 5, it will go in and it will show 5, then it will decrement, then it's greater than equals to 0. So then it will be 4, then it will show 4, then it will be 3, then 2, then 1, right? And when it will be 1, it will show 1, then it will decrement 1, so it will be 0. So 0 is greater than or equal to 0, so it will go in and show 0, then it will decrement it by 1, so minus 1, then it will check minus 1 greater than equal to 0, so that is false, so it will come out of the for loop. So we'll get 5 4 3 2 1 0, right? Here we have a decrementing while loop example. So we have I equals to 5, and we are saying while I minus minus. So we know whenever while is given 0, that means 0 tells that it's false, right? So while 0 will be false. So first we are saying I equals to 5, we are while I minus minus. So we are saying while I, so it will check while 5 after. So we know there are two types of increments and decrements: pre-increment and post-increment, and we have pre-decrement and post-decrement. Let's see this in detail now. So we have pre increment, so that is plus plus. For example, you have a variable a, so pre increment will be plus plus a, right? And and post increment will be a plus plus. Then you have pre decrement, that is minus minus a, and post decrement a minus minus. For example, you have a is equals to 5. So what plus plus a will do, it will increment the value of a first, so it will set a to 6, and then it will return the value of a. What a plus plus will do, it will first return the value of a and then increment it. So plus plus a will return 6, but a plus plus will return 5, though it will first return, because it will first return the value of a, that is 5, and then it will increment the value and it will change it to 6. Same with pre-decrement and post-decrement. When we say minus minus a, it subtracts the value of a first, so it will subtract the value of a and then it will return the value, the new value. But with a minus minus, it will first return the value of a and then it will subtract it. So it will first give 5 and then it will subtract it. So over here, what we were doing, we are saying while I minus minus. So I minus minus is post decrement. So we have int I equals to 5. So I minus minus will subtract the value of I, but it will return 5. So first it will return the value of I, then it will subtract it. So first it will give us 5 to the value that is true, and then it will decrement it, then it will set it to 4. So while 5 that is true, so it will go in and show 5, right? Then again it will check, then it will say I minus minus. So once it's minus minus, so it will say 4 minus minus, so it will first give 4 and then it will decrement the value of I, then it will set it to 3. So while 4 it will get 4, so it will then print 4, right? But the value of I will change to 3, right? And then this will be I minus minus, so 3 minus minus. So while 3, so while will get 3, but the value of I will decrement. So I will be 2 at that time, so it will go in, it will show and so on. So it will show first 4 3 2 1 0. Oh, all right, so I missed one point. I said I expected, I was about to say it will show 5 4 3 2 1 0, but it's showing 4 3 2 1 0 because it's first saying it's first checking the value of I. So I will be 5, right? So 5 is true, so it will go in, but after checking the value it will decrement it, right? So it will be 4. So when it will go in, the value of I would have already decremented and it will show 4. Then it will check I minus minus, so 4 minus minus. So uh, it while will get 4, right? So while over here, while first got 5, and then over here I we got 4, right? So when we said I minus minus over here, we over here got 5 and in here we got 4. Okay, and then in 4 minus minus, the while loop got the that check condition to be 4, but inside we got 3, right? Then it checked for 3 and inside we got 2. Then it checked for 2 and inside we got 1, right? And then it checked for 1, inside we printed 0, and when it checked for 0, 0 evaluates to false, so it will come out, it will give a new line, right? So this was one while loop in this code example. There's another while loop over here in this code example. We have I so first of all, is this while loop clear? If there are any doubts, feel free to ask, as this was kind of a new concept for us.
No, no doubts.
All right. So the next while loop over here, we have I equals to 5. Then we are saying while I, so till i's value is true, we have C out I, and then we are saying I minus minus. So here over here, first we will get 5, 5, and then it will print 5, right? Then it will decrement the value of 5, so it will be 4. Then it will check for 4, then it will print 4, then it will decrement, then 3, then it will print 3, and then it will decrement, then 2, then it will show 2, then it will decrement, then 1, it will show 1, right? Then it will decrement. So when it will check for 0, 0 is false, so it will come out. So over here in the first example we got 4 3 2 1 0, and in the next example we got 5 4 3 2 1. right? Now we also have a do while loop example over here. So over here we have int I equals to 5. We are saying in do see out I, right? So we are the i's value will be shown at least once, so 5 will be shown. Then it will over here they are saying I minus minus directly in here. So we are just gonna uh, keep track what values of I we are getting. So first time we got i's value to be 5 over here, then I minus minus, so it will decrement the value of I, but first it will return the value of I. So it will while will check for 5, so 5 is true, right? But when then it will go in and we will get 4 in over here, so it will show 4. Then it will show 4 minus it will check for 4 minus minus, so while 4, right? And it will decrement the value of I, so 3. Then it will get while 3, but it will decrement the value, so over here it will show 2. Then it will say while 2, but it will decrement the value and show while 1 over here. And when it will be while 1, it will decrement the value and shows 0. But when it will check for 0, 0 is false, so it will come out. So 5 4 3 2 1 0 will be shown. So is the do while example clear?
Yeah, it's clear.
All right. And over here we have one example over here. So let's just see this. We have for int I equals to 1, I less than equals to 5, I plus plus. So I is 1 over here, so it will check till I is less than equals to 5, I plus plus. So first I will be set to 1, right? I's value it will check for the condition, so that's true, so it will go in and show the value of I. So it will show 1, then it will increment the value of I, right? Then it will check the condition, then it will show 2, then it will increment the value of I. It will check the condition, then it will show 3, then 4. And then after 4, when it will increment the value of I, so it will set it 5, set it to 5. Then it will check the condition, that is true, so it will come over here and it will show 5 also, right? So it will show 1 2 3 4 5, as once it increments the value after that, after 5, it will be 6, right? And when it checks 6 less than equals to 5, it will be false, so it will come out, right? So we'll get 1 2 3 4 5, so we are getting 1 2 3 4 5. All right. uh, Next, in the j's example, we are setting j equals to 1, and while j is less than equals to 5, right? So over here we have while loop, over here we had the for loop. So in while loop we are saying printing j, so first 1 will be shown and then we'll increment, then uh, 2, then 3, then 4, and after 4 will be shown, it will be incremented, so 5. So then it will check 5 less than equals to 5, so 5 less than equals to 5 will give us true, so it will print 5 also. And then it will increment the value of j, right? So it will check 6 less than equals to 5, so that is false, so it will come out. So 1 2 3 4 5 again will be shown, so 1 2 3 4 5 will be shown, right? Then we have a do while loop, so k equals to 1, so it will go and it will show the value of k, right? So it will show 1, right? And then it increments the value of k, so it will set k to 2, right? Then it will check the condition, so 2 less than equals to 5, right? So that's true, so it will go and it will show k 2, and then it will set it to 3. And once it's set to 5, it will check 5 less than equals to 5, it will go and it will show 5, right? And then it will increment the value, so it will set it to 6, right? And then 6 less than equals to 5, that is false, it will come out. So this also will show 1 2 3 4 5. And then we have our previous example, our vector example that we had. So over here we are creating a vector, integer vector, right? About which we are gonna see further in this tutorial. We are also gonna see about vectors in detail. So over here we have vector, we are creating an integer vector, my vector, in which we are saving 1 2 3 4 5. Then we are taking each element of my vector in an element variable, and we are executing each element. So first we'll get 1, then 2, then 3, then 4, then 5, and 1 2 3 4 5 is also shown, right? So over here there were 4 examples of loops: a for loop, while loop, do while loop, and then a range based loop, right? So a range based loop, or you can say the for each loop, that we learned in the basic chapter also, basics course also. All right, so next we have one more example that we are gonna see over here. So we are see out we are first printing for loop, then we are looping for I equals to 0, I less than 5, I plus plus, and we are printing I. So first 0 will be printed, then 1, then 2, then 3, then 4, and when 4 will be printed, then I will be incremented. So I's value will be 5, then it will check 5 less than 5, that is false, so it will come out, right? So 0, 1, 2, 3, 4 will be shown. Then in the while loop we are setting j equals to 0, j less than 5, and see out j and j plus plus. So first 0 will be shown, then it will be set to 1, then 1 will be shown, then 2 will be shown, then 3 will be shown, then 4 will be shown. Then once j is 5, it will check 5 less than 5, that is false. So it will come out. So the while loop will also show 0, 1, 2, 3, 4. And then we have an example of do while loop. We have k equals to 0, we are showing k, so 0, and then we are incrementing it. So 1 less than 5, then it will 1 will be shown, then 2 will be shown, then 3, then 4, right? So 0, 1, 2, 3, 4 will also be shown in do while loops. So we saw two examples right now. One of for loop while loops, two while loops, and range based for loops, that is also our for each loop. And we saw another example of for loop while loop and do while loop. All right, so now we are just gonna move on to some theory part, that are the advantages of all loops, right? Then what advantages that we have when using loops. Alright, so first advantage is high performance. So C++ is a compiled language that can produce efficient and high performance code. Right, so it allows low level memory manipulation and direct access to system resources, making it ideal for applications that require high performance, such as game development, operating systems, and scientific computing. Right, so over here now, because over here we are getting the advantages of C++ only. I don't believe these are advantages of loops. These are advantages of C++ only. So let's just go through them once very quickly. So C++ is a compiled language that can produce efficient and high performance code. So one advantage is that it produces high performance code. It allows low level memory manipulation. So you can directly handle memory, and you get direct access to the system resources, making it ideal for applications that require high performance, right? So your code is not slow, it executes fast and all, right? So it's you can directly access your low level memory, and you can directly manipulate memory. So it's C++ is ideal for game development, development of operating systems, and scientific computing. Next we have one advantage of C++ object oriented programming. So C++ supports object oriented programming, allowing developers to write modular, reusable, and maintainable code, right? So you are able to write modular, reusable, and maintainable code, right? So it provides features such as inheritance, polymorphism, encapsulation, abstraction, that make code easier and to understand and modify. Right, so it's object oriented, so you get loads of new features, right? And we have already seen features like inheritance, polymorphism, encapsulation, right? In our basics course, we are gonna see abstraction in this course only, in advanced course, right? Then we have wide range of applications like C++ is a versatile language that can be used for a wide range of applications, including a desktop applications, games, mobile apps, embedded systems, and web development. So you can use it for lots of things, for development of lots of applications, right? So it is also used extensively in the development of operating systems, system software, and device drivers. So like operating systems, system software, all of these are made from C++ only. Then it's a standardized language. So C++ is standardized language with specification maintained by ISO, that is International Organization for Standardization. So this ensures that C++ code written on one platform can be easily ported to another platform, making it a popular choice for cross platform platform development. So you are able to shift your C++ code from one platform to another platform, right? uh, so that will basically it's a cross platform a language where if you write one code on one platform, it will work the same on another platform. Next, we have large community and resources. C++ has a large and active community of developers and users with many resources available online, including its documentation, tutorials, we have libraries, and we have frameworks, right? So this makes it easy to find help and support when needed, right? So there are many people to help when you have doubts in some concept or something. There are many people to help online, and it's widely used. So there's lots of documentations, videos on C++, which will help which will easy up or help with the development process. And then first we have interoperability with other languages. So C++ can be easily integrated with other programming languages such as C, Python, and Java, allowing developers to leverage the strengths of different languages in their applications. So it's saying that other languages features and other languages codes can be integrated, right? So C++ can be easily integrated with other programming languages such as your C language, right? Who That is a subset of C++ only. Then you have Python, Java. So all of these can be integrated with C++, allowing developers to leverage the strengths of different languages in their applications, right? So overall, C++ is a powerful and flexible language that offers many advantages for developers who need to create high performance, reliable, and scalable applications, right? So this was the ends of the loops chapter. Now we can move on to the conditions, right? So the conditional statements chapter, right? So let's just read the theory part of it right now, as the meeting is about to end, and we are gonna see the code and all of that in the next class. So the conditional statements, also known as decision control structures such as if else, switch, etc., are used for decision making purposes in C++ programs. So these are used for decision making. They are also known as decision making statements and are used to evaluate one or more conditions and make the decision whether to execute a set of statements or not. Right, so these statements, through these statements, you can make decisions whether to execute something or not. So these decision-making statements in programming languages decide the direction of the flow of the program execution. Right. So we are gonna see in detail the if, else, elif, else if, and all of these statements, conditional statements. So, what is the need of conditional statements? There are some situations in real life when we need to make some decisions, and based on these decisions, we decide what should we do next. Similar situations arise in programming also, where we need to make some decisions, and based on these decisions, we will execute the next block of code. For example, in C, if X occurs, then execute Y, else execute Z. So if some condition X occurs, then you can execute Y, else execute Z. So this is one example of a condition. There can also be multiple conditions, like if X occurs, then execute P, else if Y occurs, execute Q, else execute R. So this is just a very uh, uh, very small example of if, else if, and else statement that we're gonna see in very much detail, right? So this condition of C, else if, is one of the many ways of importing multiple conditions. So you have many conditions. You have if else if, you have nested if, and we have the switch statement, right? And we are gonna continue with types of conditional statements in C++ in the next class. So I hope you like the class.
Yeah, thank you.
Thank you.